Hi, my name's Thomas Baker, and I'm a Canada Research Chair in the area of quantum computing for the modeling of molecules and materials, which essentially means that we come up with better strategies to solve quantum chemistry on a quantum computer. Computing is all about information. On a classical computer, you're shuffling around bits, charges, electrons, into different places on the computer so that you can manipulate information in a particular way. The weird fact about quantum computing is that particles can be in more than one state at a time and can be entangled with each other. And what this means is that we can have the opportunity to make a fundamentally new type of computation based on this new entangled information. So one of the things that we do is we try and come up with better algorithms to solve quantum chemistry problems, which essentially means that we want to make it so that we can simulate what would happen in a chemical reaction or in molecules, and then come up with better strategies to solve them so that we can make newer and better technologies. It's not easy to simulate all of these quantum states on the quantum computer, and in order to fully understand how the quantum computer can best be constructed and best used, we use high-performance computing in order to try and simulate what are called low-depth circuits on the classical computer and basic components of the quantum computer so that we can predict what's going to happen when we finally get around to making them.